Okay, so welcome to my series lecture for the preparations for American mathematics competition, so grade A. So we will use this book. Okay, okay. So let's say the content. Let's say the contents for this this book. So first chapter is the basic algebraic review, and then the let's say the second chapter 2 is about equation, chapter 3 number series, and chapter 4 sequence, chapter 5 geometry, and chapter 6 probability. So those are materials for AMC grade A. So today we will check the chapter 1, so basic algebra. So let's say, so we just start from very beginning. So math is about numbers. So then the numbers, the simplest numbers are integers. So like 1, 2, 3, 4 is integer. Then integer over integer are fraction. 1 over 3 or 13 over 21. Then we can regard the fraction as a division. So we also have this decimal numbers like 3.124 or 6.441. So those are numbers. Okay, so let's check fractions. So we say those are fractions 2 over 3, 2 over 14. But 2 over 14, this is, even though this is a simple fraction, but it can simplify furthermore. So we have the 12 over 14 can simplify to 6 over 7. So we call this 6 over 7, this reduced form. Okay. So for those fractions, we have proper or improper fractions. Like 2 over 3, this is proper. So 11 over 3, we can call this improper. So this we can see that this numerator is larger than denominator. Right? 11 over 3 can written as 3. Oh, this make me. Let's say this should be 2, right? Okay, 11 over 3 equals 3 and 2 over 3, right? Yeah, okay. So for fraction, we have addition, and subtraction also we have those operations. Addition, subtraction, multiplication, and division. So here addition, so we should make the denominators the same. Like here, there's 3 and 5. We should make use common denominator, so which is 15, right? So we just changing this, use this denominator 15. So 2 over 3, changing so there's a denominator 3 become 15. We multiply 5, right? So numerator 2, we also need to multiply 5, and 4 over 5. So this is 5 become 15. We multiply 3. So this is 4 also need to multiply 3. 4 multiply 3 is 12. 4 multiply 3 is 12. So that's equal. This is 10. So this is 12. Okay. So here, let's say the denominator here 15, 10. There, so here 3, 5. The common denominator is we just 3 multiply 5. But for 15, 10, we don't need use 150, not 15 multiply 10. We just use 30 is enough. So we call this 30 as least common denominator. Okay. So 30, so 2 over 15, so denominator becomes 30, so just multiply 2, so this become 2 times 2, 4, and here from 10 to 30 we multiply 3, so here 3 multiply 3 become 9, so this equal negative 5 over 30. So negative 5 over 30 we can simplify for the more, right? Okay. Okay, so multiplication and division. So for multiplication, we just say like so. Denominator multiply denominator, numerator multiply numerator. This equal 8. 2 multiply 4, 3 multiply 5, 15. So for division, we can change this division as multiplication. Multiply reciprocal for this. So 4 over 5, 5 over 4. So this become 10 over 12. And 10 over 12 can be simplified as this, right? Okay, so we have those kind of problem like so this one, so multiply those, so we can, so for those problem we can do those addition first, or we can do one by one, right? So this multiply half equal like first one, this multiply half, cancel 2, becomes 3 multiply 4, 12, right? So that's equal 12 plus. So this multiply 1 over 3, cancel 3, so that's 8. So this multiply 1 over 4, cancel 4, equals 6, right? So that's equal 26. So for fractions, so we have a complex fraction. So complex fraction is just a fraction of a fraction. Just like so fraction. So we also can say fraction. Fraction line is a division. So this one like 2 over 3 divided by 4 over 5. We can regard this as just this number over this number. So this is the complex fraction. So how can we simplify the complex fraction? We just let's say one way is we changing this division as a multiplication. So the other way is we don't like this 3, we don't like this 3, we don't like this 5, so we just multiply 15. Right? So multiply 15 here, multiply 15 here. So we get this. 3, 15 cancel this 5, so this become 10. And 5, 15 cancel become 12. So again, so this also can simplify. Final answer is this. So we say, like, so this divided by this, so we also can regard this as 1 plus 2 over 3 over 2 minus 4 over 5. So this is like a complex fraction. So for complex fractions, the idea same. We don't like this 3, we don't like this 5. So we multiply 15 to get rid of those denominators. So multiply 15, okay? So each one multiply 15, 1 multiply 15, 15. And 2 over 3 multiply 15, let's say 2 over 3 multiply 15 equal 10, right? And 2 multiply 15 is 30. And 4 over 5 multiply 15 equal 12. So we can get the result. So this equal 25. So here is 18, right? Okay, so we do have those kind of problem. Like this number, this is complex fraction equal which one? A, B, C, D, E. So you need to find the correct answer. And so the idea is the same, right? We don't like 2, we don't like 3, so multiply 6. So for this one, let's say the same. We don't like this 3. So we just multiply by 3. So this multiply 3, 6. This one multiply 3, 3. And this is 2 over 3 multiply 3 become 2. So the answer is 6. Okay. So let's say the complex fraction can be this over this over this. So we have like look at the quite complicated complex fraction. So for those kind of problem, so we can do one by one. Like we just check. Let's say for this one, for this part, we don't like this 3. So we just multiply by 3, right? So multiply by 3, so this one becomes 3, and 2 multiply 3 becomes 6, and this 1 over 3 multiply 3 become 1. So this become 1 plus, so here 3 over 7, right? So here we don't like this 7. So again, so we need to do this. So multiply 7. So here, so we should multiply 7 for numerate and denominate. So here multiply 7, here multiply 7, and this multiply 7 becomes 3. So final answer is 7 over 10, right? Okay. So for fractions, sometimes we want to compare which one is big. So a decimal numbers also very easy. Like compare decimal numbers very easy, like a 2.15 or 2.45. Which one be big or this one big? Very easy, right? But for fractions, sometimes not so easy because the denominator is not the same. So one way we can do is just changing to decimal. But sometimes you just changing to decimal take too much time. So we try to have a quick way. Let's say the quick way is so here for this one. Let's say for comparison 2, we say we can change the common denominator. So this become 15. So we need to just only compare the numerator. So 2 over 3. So if denominator become 15, we multiply 5. So this become 10, right? And 4 over 5. 4 over 5. So here we multiply 3, so this become 12. So then we can say, oh, this is big, this is large. But if we have many those questions, many those numbers, we want to find which one is biggest. So in this way, we try to find a pattern or a trend. Like first one is 2 over 3, 4 over 5, 6 over 7, 8 over 9. So what is those numbers? So we can find those numbers have denominator equal numerator plus 1. Right? So if we denote the numerator as x, then this fraction like x over x plus 1. So we want to check it out when x become large. So we say x, we just use this. X become increase. So this number increase or decrease. So we just pick, let's say, so we can say, so when x equal 1, so this number is half, right? 1 over 2, 1 plus 1. So x equal, x become very large, so we use this notation, x goes to infinity, like x goes to infinity, very large, saying x plus 1 and x quite the same. Like for example, x 1000, so 1000 plus 1 and 1000, almost no difference, right? So we say those things will, those things will close to 1. So let's say from half to 1, so this is increase, right? From half to 1 increase. So we know those numbers just increase. So this one is biggest. Okay. So let's say, like for this problem, like we have five fractions. We want to check. We want to find which one is the largest. So here again, we just check what is the common in those fractions. So 3 over 7, 4 over 9, 1735, 100 over 201. So we just check numerator and denominator. Okay. So let's say for this one, we can say this is just like those problems. If numerator is x, then denominator 2x plus 1, right? And also this one, right? This x 4, 2, yeah, also this, right? And this one 17, 34, 17, yeah, this also, we can find all those are just like x over 2x plus 1. But this one not. This one is what? This one is like if this x, if 151x, this is multiply 2, become 1, 3. So this become 2x minus 1, right? Yeah, okay. Okay, so let's say, so at first let's check this 4, which one is bigger. This 4, which one is big? So we check those numbers when x, become big, these numbers increase or decrease. So we just check like when x equal 1, this number is 1 over 3, like 2. Yeah. So when x become very large, so this x over 2x plus 1, so we can forget this 1, just the x over 2x, just half. So we know 1 over 3 half. So this increase, right? So 1 over 3 small. So we know for these 4 numbers, this is bigger. 100 over 201 is big. Okay, so then compare these two, D or E. So we can say like D or E, this is like, okay, we also can check like here's let's say here is minus 1, here, so we also can say like if this D or E become like 151, so and here 2x plus 1 is 300, 300 2 plus 1. Okay. Okay. But anyway, like, okay, so we find this one is big. This one is big because this is plus 1, this is minus 1, the denominator smaller, so this is big. Or we can say we just need to check up DOE. And the DOE, we can say D is, let's say, E is larger than half, right? Larger than half. And D is less than half. So E is biggest. Okay, so now let's check some problems involved fraction. So this is a typical example in your class. 2 over 3, those part of students like math, those part of students like sports, and those part of students like music. So what is the smallest number of students in your class? So we say those part of students like math. So your total number should be can be separated by 7. So total number should be 7 times some integer, right? 7k. So total number can be 7, like can be 14, can be 21, like cannot be 10, right? Yeah. So should be a multiplication of 7, and also like should be multiplication of should be like so we just check out in should be like 7 or 14 or 21 and 28 like this, right? Can be multiplication of 7, and also in should be multiplication of 5. 5 would multiply some number. And also this n should be 2 multiply some number. Okay, so from here we can say smallest n should be 7 multiply 5 multiply 2. Okay, so should be at least 70 students. Okay. Okay, so this problem part is the same, right? We say 1/3 of her marbles are blue. So we say 1/3 are blue, and 1/4 are red, and 6 of them are green. Okay. And 6 of them are green. 6 green. So what is the smallest number of yellow? No, have also yellow, yes. So yellow. Okay. So let's say the total number of marble. Total is n. So we have this n equal blue one, so 1/3 n, right? So plus red one, 1/4 n, plus green one is 6. Then plus so yellow one I don't know. I put this x. Okay, so here x and n should be integers. So we just try to find the smallest x. So here let's say so n. So here we put n together. So this we have this. Let's say in 1. So 1 over, let's say 1 over 3 plus 1 over 4 equal 12 over 7, right? So here, just like this, I add them up, the 7 over 12n plus 6 plus x. And we move into this side. So 5 over 12n equal 6 plus x. Okay, so we just multiply 12. So 5n equal 12 multiply 6 plus 12x. Okay, so let's say, so this multiply this 12 multiply 6, 72 plus 12 times x. Okay, so 72 plus 12 times x. Excuse me. So this number should be a multiple of 5. So let's check So let's check x. So x equal 1, no. X equal 2, no. X equal 2 because 72 plus 24. This is not a multiple of 5. And 3 not work. 4 works, right? 72 plus 48, right? So we find x equal 4. Okay, so we say for number we have a fraction and a decimal. So sometimes we need to change the fraction to decimal. So we can use division, like 2 over 25. So 2 divided by 25, we can do this way. 2 divided by 25, plus 8. Okay, so then 0 point, put 0, so here, okay. At first, we should put 0 here, yeah. Then here we find this equal 8, right? Okay, so we say this equals 0, 0, 8. But so here, but this is, but here we try to find some simple way sometime. So we say changing to decimal is just changing to base on 10. So here, let's say if we, so this 0, 0, 8, also we can say this equal to 8 over 100. Right? This is 0, 0, 8. Like, so decimal just like, let's say it's based on 10, like 0.12, so equal 12 over 100, right? So we can change this problem as changing this denominator from 25 to 100. So how can we change? So we say, this one is equal. If we change it to 100, then numerator we just should multiply 4. So here multiply 4, here multiply 4. So we say that's equal 8 over 100. Or this is 0.08. Okay. So we know that some number like we can easily change to denominator to 10, 100, 1000. Like 25 multiply 4 equal 100, and 125 multiply 4 equal 1000. So we can, like for those problems, we can easily to change the fraction to decimal, like 8. 8 we can say 8 we just multiply 1 to 25. So here 3 multiply 1 to 5. So this equal 1000. And this one multiply 5, 1 to 5, to multiply 5. So we can say this 3 over a equal 0.375. So for 20 over 3 over 20, this is easy, right? So we change it to 100. So here multiply 5, so this become 15. So this equals 0.15. So if the denominator can be those numbers like 2 or 4 or 8 or 5, 20 or 25, those we can use this method. But in general, like if the denominator is those 3, 6, say not so easy to change into 100, then we use division. Okay. So let's say then changing decimal back to fraction. So we just say like 2.1. 0.1 is 2.1. So we just 0.1 become like a denominator 10. So 2.1 we can change that to 21 over 10, right? So 3.5 can change to 35 over 10. 35 over 10 can be simplified of 7 over 2, right? Okay. So not all decimal can change into fraction. Only those but those repeating decimal we can change into fraction, like 0.3333. So we can say this is just the repeating decimal. So this is just equal just 3 over 9. We just say 333. So 3 over 9. So 0.4444. Just 0.44444 like this. Always the 4. Then this is just 4 over 9. So if here we have 2 digit repeated, 34, 34, 34, then this is equal, so 34, so here denominator become 9, 2 numbers, right? So 63, 63, so just the 63 over 99. So this one we can simplify for us. Okay. So here we just use if here how many digits repeat. So then we need to check put how many 9s. Okay. So this one we can simplify to 1 over 7. But anyway, like here, this is the way for changing these repeating decimals to fractions. Okay. So if someone we have infinite digits but not repeating, then those numbers cannot be changed to fraction. So we call those as irrational numbers. Irrational means not reasonable. So before people believe all numbers should be changed to fraction, but we do find we do have some numbers cannot change into fraction. So we just call those irrational number. So typical irrational number just radical numbers, radical 2, radical 3, radical 2, radical square root of 2, square root of 3, or square root of 4. Or this is okay, right? So this 5 not okay, 6 not okay. Like all those are irrational number. And also have a really famous irrational number is pi. Pi equal 3.1415. Infinite digits. Okay. So we can so we just stop here. So next lecture we will continue. Okay.